Welcome back guys again to another BrainFlex video. In this one, we're going to talk about uncertainty in measurement. Okay, let's begin by defining what uncertainty is. So when you hear of uncertainty, it means doubt in measurement. So if you measure something and it happens that you have some doubt on how accurate your measurement is, that doubt is what we call uncertainty. So let's say you measure the length of a particular object as 13.30. Your doubt can be written as 0.05. And this part, the 13.30 is what we call the central value. Central value. Then this part, if it's written as a decimal number, it's called absolute value. Take note, if it's written as a decimal number, we call it absolute value. But if it's written as a percentage, let's say it's written as 0.02%, this one we call it percentage uncertainty. So these two, they are not one and the same. You will see as we progress in this video. So yeah, take note of that. So since this one is written as a decimal number, we call it absolute uncertainty, not absolute value, but absolute uncertainty. We call it absolute uncertainty. Okay, our main focus will be on combination of uncertainties. Yeah, that will be our main focus. So I'm going to explain the three rules that you need to know under uncertainty. So there's a rule that governs addition and subtraction. Then we have the second rule that governs multiplication and division. Then we're going to talk about the rule that governs formulas that have powers in them. Yeah. Okay, let's begin with addition and subtraction. So we're saying addition and subtraction. So for any mathematical operation that involves addition and subtraction, you need to add. So the rule states you add absolute uncertainty. So let's call this one rule 1. So this one is our first rule. So our rule 1 states if you're dealing with addition and subtraction, you add the absolute uncertainties. Okay, to best understand this one, let's take this example. Let's say we are given a shape, a triangle by the way. And let's say this side is a 7.11 plus or minus 0.03 centimeters. Then this side, let's give it a 3.70 plus or minus 0.05 centimeters. Then this side, let's say it's 6.90 plus or minus 0.02 centimeters as well. Then let's say the question says find the parameter. Find the parameter with uncertainty. So we need to consider uncertainty when calculating the parameter. Okay, how do you go about a question like this one? So remember, these ones are called what? Central values. So if you're given a question like this one, you need first to understand what parameter is. So parameter is that's the sum of all the sides of a shape. So for this shape, the parameter is the addition of this side, and that side. So the total sum of all this length is what we call the parameter. So we can calculate it by 2 steps. Remember, this one we add absolute uncertainties. Keep that in mind. Okay, I'll love this part. So our step 1 should be working out. So we're going to work out the central values. Central values. So in this case, we are saying parameter of central values, so we're dealing with the central values, will be equal to, we're going to add all the central values. So we're going to say 6.90 plus 7.11 plus 3.70. And that will give us, so you can punch that into your calculator, 6.9 plus 7.11 plus 3.7, and that will give you a 17.71. So we need to keep this one. It will be needed on our final answer. Now your step 2, so let's get rid of these things. Your step 2 will be working out the uncertainties. So this time we're going to say you work out uncertainties. So to work out your uncertainties, we know that under addition and subtraction, remember parameter has to do with adding. So under addition and subtraction, we add the what? The absolute values. And in this particular site, we are given absolute values. We know that because they are written in decimal places. They are written as a decimal number. Yeah. So these ones are absolute values. So you just add them. So we are saying parameter at the uncertainty side will be equal to 0.02 plus 0.03 plus 0.05, and that will give us 0.02 plus 0.03 plus 0.05. This one will give us a 1. So we're going to get a 0.1, by the way, not a 1. 0.1. So 0.1, that's our absolute uncertainty. So we can now get rid of all these things and write our answer. So we have 2 values. We have this one and that one. Remember, our answer must consist of the central value and the uncertainty part. So we are going to write answer will be 17.71 plus or minus 0.1. Now take note of this. If you write your answer this way, you will be marked wrong. Reason why, when you're writing your uncertainty or you're writing your particular measurement with uncertainty, the number of decimal places on the central value must be the same as the number of decimal places at your absolute uncertainty. So here we need to include a 0 at the end so that they match the number of decimal places or decimal numbers in each part. So you write it this way. And don't forget to include the units. The units were centimeters. So that's how you answer a question of this kind if you are told to find the parameter with uncertainty. So this is your answer. Yeah. Okay, now let's work out another example under this loop. This time let's say we have minus. So let's get rid of everything. Remember, we need to do it in 2 steps. 2 steps always. So this time let's say we have a question this way. Let's say evaluate. Let's say evaluate 0. Okay, let's say 10.01 plus or minus 0.02 meters minus open 9.08 plus or minus 0.01 meters as well. Then we are told to evaluate this one. How do you go about it? Remember, it's minus, so we can just add the absolute uncertainties. Okay, let's do it. So we begin by working out. So we're saying step 1, we need to work out the central values. So we are saying 10 has to be added. So we are saying 10.01 has to be added by 9.08. It has to be added with 9.08, which will give us, so when you punch your 10.01 plus 9.08, you're going to get a 19.09. So this one, it's your central value. Now let's work out our uncertainty. So we are saying work out uncertainty. Okay, this time let's say uncertainties. Yeah. So this time we are going to get the absolute values. So the absolute value, that one has to be added with 0.01, which will be equal to 0.03. Then your final answer can be written as, you can write it as 19.09 plus or minus, then you include your uncertainty, your absolute uncertainty. Don't forget to include the units, which is meters. So that's how you solve a question of this kind. Okay, now let's jump into the next rule, which is the rule that governs multiplication and division. So let's get rid of everything. Okay, so if you're playing around with division or multiplication, you need to add percentage uncertainties. Take note, under addition and subtraction, we are adding absolute uncertainties. This time we need to add percentage uncertainties. Okay, now what's percentage uncertainty? Percentage uncertainty can be determined using this formula, where we say percentage uncertainty is equals to absolute. The absolute uncertainty divided by the central value. So you divide it by the central value multiplied by 100%. Yeah. So you multiply it by 100%. So that's how you find the percentage uncertainty. Percentage uncertainty sometimes is also called the percentage error. Percentage error limit, yeah. Or you might hear of it being called relative uncertainty. So sometimes it's also called relative uncertainty. So all these names refer to percentage uncertainty. Okay, let's handle a question to understand this better. So this time, let's say we are given a rectangle. Let's give this side a 5.05 plus or minus 0.05 centimeters. And let's say this side it's a 12.1 plus or minus, okay, let's say 10 plus or minus 0.03 centimeters. And the question states, find the area of the shape with uncertainty. So we need to consider uncertainty. So with uncertainty. So how do you go about a question like this one? Okay, so let's just get rid of everything on top. So first thing first, we know that area as this formula, area times area of a triangle, it's width times length. That's how we calculate the area of a triangle. And we know that the relationship in this formula is multiplication. So we need to add percentage uncertainties when calculating the uncertainty part of our answer. Okay, so let's do it. As usual, our step 1 will be working out the central values. So we're saying work out central values. Okay, so central values, we have this one. So we are going to say area. This time it's at the central value. Will be equal to 5.05 times 12.10. Punch that into your calculator. You're going to get a 17.06 as your answer. So this one is a central value. Now let's find our uncertainty part of our answer. So to find the uncertainty in this question, I'll get rid of these things. This time we are saying step 2, let's call it step 2. Let's let's work out uncertainties. Okay, and I want to keep that value 17.06. So I'll get rid of these things. So now to find the uncertainty of our solution, we need to add the percentage uncertainty. But what we have here, it's absolute uncertainty. So we need to convert them into percentage uncertainty. Let's do it. So this side, we can convert it as uncertainty. Percentage uncertainty will be equal to absolute value 0.05 divided by the central value times 100%. And this will give us 0.05 divided by 5.05 times 100. Okay, this one will give us a 0.99%. Okay, so we are done this side. We can get rid of it. Okay, wait a minute. We'll be needing some of the values. We'll be needing this value. So let me get rid of this part. Okay, so now let's find the percentage uncertainty of this other side. So percentage uncertainty this other side to be 0.03 divided by 12.1 times 100%. Okay, so when you punch that into your calculator, you are going to get a 0.25%. Okay, so now we have these two values. What we need to do now, we need to add them. Yeah, we need to add them. So now we can get rid of this part. So we need to add them. So we're going to say 0.99% plus 0.25%. Okay, these things, I can get rid of them. So when you work out this one, plus 0.99, you are going to get a 1.24%. So your answer can be written as, so you can write your answer this way: 17.06 plus or minus 1.24%. Don't forget to include the units. So the units were centimeters, I guess. So you include the units as well. So that's how you can write your answer. But there is a better way of writing your answer. Suppose that you want to write your answer with a decimal number this side. How do you do it? Let me show you. Let's get rid of everything this side, including these things. So if you want to write this one as a as absolute uncertainty, what you need to do, you need to say the formula for uncertainty, percentage uncertainty, looks this way. It's absolute uncertainty over central value times 100%. So in this case, we have the percentage uncertainty, which is 1.24% is equals to, the absolute is what we want. So we want to find the absolute uncertainty. Then the central, we have it, it's 17.06 times 100%. So now these things are no longer necessary. They can disappear. So now, to find the absolute uncertainty, so we're saying absolute uncertainty, you can now just say, 1.24% divided by 100% times 17.06. And this part will give you this one divided by 100 times 17.06. That will be 0.21. So the other way of writing your answer is 17.06 plus or minus 0.21. So these are the two ways of expressing your answer. Okay, let's now jump to the last law that you need to know, which is the law that governs formulas with powers. Let's get. Okay, so we are told that we are given a cube with one side measured as that. Then we are told to find the volume with error limit. So when you hear of error limit, it's the same as uncertainty. So we are told to find the volume. So now we know that volume of a cube is L to the power 3. Or you can use V is equals to L times B times width. Now we know that this side and that side is equal to L, so we can write it this way. Okay, now I want you to pay close attention. I will begin by using this formula so that I show you the relationship between this formula, the multiplication, and that of a power. Let's begin by using this formula so that we see what I'm talking about. I'll begin by using this one. So if you want to use this one to find the volume of a cube, let's begin by drawing it. A cube is something that has equal sides. So we are saying every side has 15.5 plus or minus 0.3 meters. So in this formula, we know that the relationship with multiplication, So we need to add percentage. We are saying add percentage uncertainty. So we need to add percentage uncertainty when finding the uncertainty of our solution. Okay, let's begin by finding the central value. So let's begin with step 1. So step 1, we are saying find the central values. So the central values, as usual, we can calculate them using this formula. So it will be 15.5 times 15.5 times 15.5, and that will give us, so we are saying 15.5, that will give us a 3,723.875. Okay, we have our central value. Let's now find the uncertainty of our solution. So to find the uncertainty, since it's multiplication, we need to add the percentage uncertainty. So let's find the percentage uncertainty of what we are given. So to find the percentage uncertainty, we're going to say what was the uncertainty? Let's get rid of this. So percentage uncertainty will be 0.05, oh, it was 0.3 by the way, divided by 15.5 times 100%. So this will give us a 0.03 divided by 15. You're saying 15.5 times 100. That will be a 1.94%. Now every side will have this same value since it's a cube. So now what we need to do, we need to add all the sides, all the percentage uncertainties of the sides. So we are going to say in step 2, we need to add this 3 times. So we're going to say to find the volume at uncertainty part, we need to add this uncertainty of length plus the uncertainty of breadth plus the uncertainty of width. Remember, this value will be needed, so I don't want to lab it. Okay, so this one will give us the value 1.94 will give us the value 7.30% as your answer once you add it 3 times. So this one will be your solution at the uncertainty part. So now we can write our answer this way. Let's get rid of these things. We can say our answer will be written as 3723.88 plus or minus this particular value of uncertainty. That way. Don't forget this was in what? Meters. So that's how you can write your answer. Or we can write it with absolute uncertainty. So we need to convert this one into absolute uncertainty. Let's do it, because I'm doing so because some lecturers recommend writing it that way. So let's do it now with absolute uncertainty. So to do it with absolute uncertainty, we're going to say 7.30. Okay, we need first to look at the formula. So we know that the formula is percentage uncertainty is equals to absolute value or absolute uncertainty divided by the central value. So the central value is 3723. 0.88 times 100%. Okay, so now to work out this, we're going to say this one times that divided by 100. Okay, so your absolute uncertainty will be equal to 7.30 times 3723.88 divided by 100, and that will give us a 271.84. Let me double check my work. Okay, so that's my answer. Yeah, we need to get rid of these things. Then we are going to write it as, the alternative of writing the answer will be 3723.88 plus or minus that value, 271.84 meters. So you can either write it this way or you can write it that way. Okay, now we've done it using that formula. Now this time, let's use the formula that has a power. Let's use a formula that has a power. This time, let's say we use V is equals to L to the power 3. How do you go about it? So if you are dealing with something that has a power, remember, if you're doing something that has a power, you can take note of this. You just need to multiply the power. When determining the uncertainty, you just need to multiply the power times the percentage uncertainty. Percentage uncertainty. So power times percentage uncertainty. Okay, let's do it. So I will get rid of this one. And we are using this formula. Let's get rid of this one. Okay, so we are using this formula this time. So the central value will be the same. But let's see whether we are going to get the same uncertainty. So to find your uncertainty, using the formula that has a power, we need to say its power, which is the power is 3, times the percentage uncertainty. So to find the percentage uncertainty of this particular given size or length, we say 0.3 divided by 15.5 times 100%. That's how we calculate the percentage uncertainty. So this side, it will give us a 0.3 divided by 15.5 equals times 100. That one has to be multiplied by 3. And we are going to get a value of, let's punch it again. We are saying 0.3 divided by 15.5. 15.5 times 100. That value times 3. Okay, it's given a 5.806 percent. I think we made a mistake on this one. It must give us the same value. So let's see. This part, okay, let's see. To find the percentage uncertainty, this part, it's given a 1.94%. I don't know whether that's the value you calculated. Yeah, so that's the value it's given. So now we are going to use this one for each side. Yeah, so now let's go back to that formula we did. The V is equals to L times B times W or times H if you want. So on this formula, we know that it's multiplication, so we need to add the percentage uncertainties. So we need to add 1.94 plus 1.94% plus 1.94%. 3 times. Let's do it. So we're saying 1.94 plus 1.94 plus 1.94. I think what I did on my calculator, instead of me adding it 3 times, I went direct on my calculator and said power 3. That's different. We need to get this value. So now it's giving us that value. Try to add them. So when you add this 3 times, you're going to get a 5.806. Yeah, you're going to get a 5.0. Actually, it's a 5.15. Now we understand that the difference in these values is because of the rounding off. Yeah, but you must get cross values. In fact, the same values if you didn't round off. Yeah, during your calculations. So yeah, you need to get the same values. Remember, I just made a mistake on this part, but the rest of the solvings were correct. So yeah, either ways you need to get the same values. Now to summarize it, I'm saying when you're dealing with a formula that has a power, let's say a power of n, to find the uncertainty of your solution, you say the power, in this case it's n, times percentage uncertainty of this big given side. So percentage uncertainty of, since it's L, we know its length, so we say of length. That's how you calculate the uncertainty. But if you're dealing with division or multiplication, we said you add the percentage uncertainties. So you add the percentage uncertainties. Okay guys, let's now handle some exam questions. Yeah, let's handle some exam questions now that we've understood all the rules that govern uncertainties operations. Okay guys, we have this question from 2023 test 1. It was under question 1, by the way. Yeah, and it came with 4 marks. 4 marks. The question reads, if the length and the width of a triangular plate are measured to be this centimeters and that centimeters respectively, find the area of the plate and the approximate uncertainty in the calculated area. Okay, so we need to consider uncertainty in short terms. Okay, let's do it. So we said our step 1 must be working out the central values. So we need to work out central values. Okay, let's do it. So what are we doing? What are we dealing with? We're dealing with area of the what? Of a triangular plate. Okay, we know that area of a triangle or any kind of a box, it's L times B. That's nice. Now let's find the area of the central part. So we're saying the central value of area. So it should be 17.3 times 13.30. Let's include a 0. So punch that into your calculator, 17.30 times 13.3. And you're going to get a value of 230.09 as your answer. So this is part of our solution. So we need to write it there. Now let's lab everything and work out the uncertainty of our solution. So this time we are saying we work out the uncertainty. So we are going to work out uncertainties. So now, to work out the uncertainties, we are dealing with what? Multiplication. We said area is equals to L times B. So we are dealing with multiplication. So we need to add the percentage uncertainty. Take note of that. We add percentage uncertainty. Okay, let's find the percentage uncertainty. So for the first part, which is the length, on the length part, percentage uncertainty will be equal to 0.05 divided by 17.30 times 100%. Punch that into your calculator. 0.3 times 100. You're going to get a 0.289%. Let's keep this value. Let's find the percentage uncertainty of the width. So we are saying width. Let's come now to the width part. Let's find the percentage uncertainty this side. So the percentage uncertainty this side, it's the absolute value, which is 0.05, divided by the central value, which is 13.30 times 100%. And that will give us 0.05 divided by 13.30 times 100. Okay, when you punch this into your calculator, you need to get a 0.376%. This one, it will be also important during our calculations. Now, I will lab everything on top. Let's create some space. Okay, so now we have these two percentage uncertainties, and we said we add them. So we need to add. So we add them. So when you add them, we are saying 0.376% plus 0.289% plus 0.289% will be equal to 0.665%. We are done. Let's write now our answer. So our solution will be this value, 230.09 plus or minus 0.66, or we can say 0.67% as your solution, centimeters. So this one will be your area. Now remember, area as units, centimeters squared. Okay, square centimeters. Yeah, don't forget to do so. That's what I've just remembered. The question that we did at the beginning, I forgot to write the units in their correct manner. Please correct that part. Yeah, the question that we did at the beginning, I didn't consider writing the units correctly. So you can take note of that. Okay, so this one will be your solution. The other way of writing the solution is by writing this one as the absolute uncertainty. Let's do it. So to write it as your absolute uncertainty, you need to say this value is equals to absolute uncertainty. Let's just write it as AU representing absolute uncertainty over the central value. We know the central value is this part, 230.09 times 100. Remember, we want to convert this one into absolute uncertainty. So now, the absolute uncertainty will be equal to this value, 6.67%, will be multiplied by, okay, let's push this work down this side so that we work out this part. So we are saying 0.67% will be multiplied by 230.09. Then we need to divide it by 100% to find the absolute uncertainty, which will give us, we are saying, this particular number times 230.09 divided by 100. That will be a 1.53. Wow, 1.53. So now your answer, let's get rid of everything. Your answer this time can be written as 230.09 plus or minus 1.53. Remember, the number of decimal places must be the same, and your unit is centimeter squared. So these ones are our possible solutions. You can either express your answer as this way. Remember, if you write it this way, you need to put percentage this side. If you write it this way, then don't put percentage because you are writing it as the absolute uncertainty. This one, you've written it as percentage uncertainty. Okay guys, that's how we go about a question of this kind. Let's handle one more question, then call it a day. Okay, let's answer our last question. So here's a question from tutorial sheet 1. So this question is from tutorial sheet 1. 2022. So we are saying tutorial sheet 1, 2022. And we are going to answer question 5. Remember, questions of this kind come with 4 or 5 marks. Yeah, so this one, maybe it might come with 5 marks. Okay, let's unweight. We are told that a plate has this length and this width. Then we are told to calculate the area of the plate, including its uncertainty. Okay, as usual, our step 1 will be calculating the central values. So we're dealing with what area? We know that area is equals to L times width. So we're going to say area will be equal to 9.8 times 21.3. Let's punch that into our calculator. 9.8 times 21.3. And you're going to get a value of 208.74. Our step 2 will be working out the uncertainties. So we are dealing with what? Multiplication. So since it's multiplication, we add percentage and certainty. Blah, 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 uncertainty. Okay, so let's read. Let's add the percentage uncertainty. Let's begin with this side. We have 0.2 as our absolute value divided by the central value 21.3 times 100%. We need to add this one plus the other percentage uncertainty, which can be calculated by saying this one times 100. Then once you add the 2, you're going to get a 0.2 divided by 21.3 equals plus open 0.1 over 9.8 closed times 100. You're going to get a 1.96% as your percentage uncertainty. So now your answer can be written as 208.74 plus or minus 1.96%. Don't forget the units, it's area, so it's squared. So you can write your answer this way, or we can write it with absolute uncertainty. Let's do so. So we can write it with absolute uncertainty. Let's get rid of everything and let's convert 1.96% into absolute uncertainty. Yeah, into absolute uncertainty. Over. So we know that our central value is 208.74 times 100%. So to calculate our absolute uncertainty, we are going to say this one 1.96 times 208.74 divided by 100, and we're going to get a value of 4.09 or 4.1 as your value. Okay, let's write it as 09. So now your answer can be written as, we can write the answer as 208.74 plus or minus 4.09. Remember, the number of decimal places must be the same. Yeah. So we need to put our units at the end, squared. So this one too is a possible way of writing your solution. So that's how you answer a question of this kind. Okay guys, thanks for watching and I'll meet you in the next video.